Hello YouTube and welcome to Let's R. In this video, we'll be taking a look at descriptive statistics. What does descriptive statistics try to do? Well, descriptive statistics summarizes or describes the characteristics of the dataset. There are two broad categories for descriptive statistics: measures of central tendency and measures of dispersion. Central tendency attempts to summarize your entire dataset into a singular value, whereas dispersion attempts to summarize or identify the spread of the data on the number line. In other words, dispersion tries to identify how far each of the data point is from the central tendency. And we'll talk about each of these in detail as we move along this video. Before we talk about any of these statistics, it's important to understand that what we use and how we use depends on the kind of data that we are working with. For this video, I've created a data set, and it's a very simple one. We have two locations, and I've been measuring temperatures for 5 days, 10 data points in total, 5 for each location. We'll use this as a reference point and go through each of the statistics. Part 1 of this video will focus on measures of central tendency. So we'll be talking about mean, median, mode. Now let's move on to what mean means, pun intended. Mean, or average as it's popularly known, is the simplest measure of central tendency. It's calculated using the formula sum of all observations divided by number of observations. In our case, we've taken location A as an example. It has a total of 5 observations. So you basically add up your entire observation, which would be 30 plus 40 plus 40 plus 30 plus 20, and that gives you a total of 160. And because there are 5 observations, you divide your total. That gives us an average of 32. In other words, what that means is your average temperature over a span of 5 days is 32 degrees. Now, mean has a few other variants. What we've dealt with right now is known as the arithmetic mean. The one problem with mean, although simple to calculate and easy to use, is the fact that it is very sensitive to outliers. To show you what I mean, let's assume that location A is now confronted with a cold front. So on day 6, it's recorded a historic temperature of negative 40 degrees. Now, if you calculate the mean, which is sum of all observations divided by number of observations, the total comes down to 120. And since there are 6 observations, you divide this value, which gives us an average temperature of 20 degrees. And that's a drop of 12 degrees just because of one day. Mean is usually best used when your dataset is continuous and symmetrical because of this reason. You want to make sure it's evenly spread out. That way you don't have a lot of outliers that affect your statistic. Now, in order to tackle the outlier issue, we have median. Median is just the central value when the data is arranged in ascending or descending order. And what I mean by that is when we arrange our current data set, which is 30, 40, 40, 30, 20, in ascending or descending order. For this example, I've chosen ascending order. The median is 30 because it is the central value. So there are 5 observations. The central observation would be the third observation, which would make it 30. Now, if the data set contains even number of data points, then you take the middle 2 and average it out, and that gives out the median. Like the mean, median can't calculate categorical data because there is no logical way of ordering people's names or any of the categorical data. Unlike mean, median isn't as sensitive to outliers. The reason is because it uses position rather than value. So in our case, just like the previous example, day 6, location A is confronted with cold front. We recorded a negative 40-degree temperature. And let's take a look at how median is affected. Again, I arranged the entire data points in ascending order, which means negative 40 comes first, 20, 30, 30, 40, 40. And median is now the average of the central values. because there are 6 numbers or data points, I take the third value, fourth value, and divide that by 2, giving me an average or median of 30. Now, median is actually preferred when your distribution is not symmetrical, which is in most real life use cases. Hence, this is the reason for why the United States Census Bureau uses median and not average to report household income. This is because the data might be skewed by very few individuals who get paid very, very high, or a few other individuals on the other extreme who get paid nothing or close to zero. Now, mode is the most frequently appearing value in the dataset. What I mean by that is you just count out the unique values that exist within the dataset. In our case, that would be 20, 30, and 40, and count how many times they occur. So in our case, 30 occurs twice, 40 occurs twice, and because these are the most frequently appearing values, the mode for this dataset is 30 and 40. Yes, this dataset has 2 modes, and there can be more than 2 modes. Hence, this dataset would be known as bimodal dataset. Unlike mean and median, mode can be calculated for both numeric and non-numeric data, which means that if you have a list of names and you want to identify the most frequently appearing one, you could use mode. Mode is limited as there can be multiple values, and in the starting, we've discussed the fact that central tendency tries to summarize your entire dataset into singular value. So, mode in most cases doesn't fully represent the entire dataset or the central value. A real time use case for mode is when a retailer wants to identify which product was sold the most for the week. For this, he can just list out all the products that have been sold and look at the most frequently selling one. In short, measures of central tendency again tries to represent your entire dataset into a singular value. They want to get an understanding for where the center lies. Mean is sum of all observations divided by number of observations. Median is the central value after arranging data in ascending or descending order. And mode is most frequently appearing number. So what would each of these statistics be for location A and location B? You can see that for location A, mean is 32, median is 30, and mode is 30 and 40. For location B, mean is the same as location A, median is the same as location A, and mode, it's not. 50 is its mode. So you could see the difference there. Now, I want to ask you all a question. Let's say you're scouting these 2 locations to set up an ice cream shop. And given that based on your market research, you've understood that higher the temperature in the region, the more ice creams you can sell. With no other factors taken into consideration, based on the statistics that you've collected just now, mean, median, mode, for each of these locations, which location would you select and why? Leave a comment down below and give us your reason. In the next video, we'll be talking about measures of dispersion, why they're important, how they can be calculated. So if you found this video useful and helpful, please feel free to leave a like, share, and subscribe. At the same time, if this was not useful, there's always the dislike button. I'll see you in the next video.